Hey, math peeps. All right, so yesterday we talked about the cosine law. The cosine law we used when we had two sides and an angle in between. That was enough information to get the third side, even though the triangle wasn't a right triangle. Or if we know all three sides, we could use the cosine law to get any one of the angles. Okay, awesome. So when we're doing trig questions, pardon me, when we're doing trig questions, we're going to kind of walk ourselves through this kind of flow chart question and answer thing, where we first say, hey, do I have a right triangle? Well, if I have a right triangle, then you're going to use sine or cosine or tangent, just like you did in grade 10, okay? If your answer is no, then you go and ask yourself, okay, do I know all three sides? Or do I know two sides and an angle? And if your answer is yes to that, you're going to be super excited and you're going to be like, hey, I get to use cosine law. If your answer is no to that, then chances are you'll be able to say yes to the last question, which is, do I have a pair of an angle with its opposite side? Okay, the sine law uses an angle with its opposite side. As long as you have that one pair, you actually can go solving for other things. Okay, and here's why. It's kind of a cool thing. I'm going to just say it, and then I'm going to build the reasoning behind it. So what the sine law states is whatever that ratio is, an angle divided by its opposite side, or a side divided by its opposite angle, it doesn't really matter what direction I go, that ratio will be the same for all three pairs of the triangle. Okay, and that's what I want to show you right now. We're going to take just a couple minutes to kind of develop that, and then we'll kind of put it into practice. So we can use, I'll just hide my big old head here for a sec. We can use the cosine law when we know SSS or SAS, but what do we do if we don't have those situations? Okay, so take a look at this. We're going to consider triangle ABC. Again, I'll hide myself for a quick second so that you can see, just like yesterday, we can call this guy here B, and this guy here A, and this guy here C. And just like yesterday, we're going to drop a perpendicular, and we're going to call that the height. Okay? Now, what can you tell me? Well, you can tell me, let me just hide myself for one more sec. Take a look at this for a sec. If I switch ink, you could tell me that the sine of B is H over C. Do you agree with that statement? Okay, the sine of B is H over C. Or you could tell me that the sine of C is H over B. Yeah? Okay, so I can get those two things. The sine of C is H over B, and the sine of B is H over C. So let's write those down. So sine of C is H over B, and then what I'm doing is I'm solving for H here. Okay, I'm going to get H by itself, because remember when we did the cosine law, we were like, okay, we got all these cool little formulas, let's rearrange them and get rid of the thing I threw into the diagram in the first place. I'm throwing in that H, so if I can somehow get rid of H by using substitutions, that would be awesome. Okay, so then in the triangle ABD, I said sine B is H over C, and I can do the same thing. C times sine of B will equal H. Well, H is H, right? This H here and this H here are not different H's, which means I can sub this H with C sine B, or if you want to think of it, I can sub this H with B sine C. It doesn't matter. Either way, I'm going to arrive at a statement that reads like this. Okay, well, now I'm going to create a fraction from this. I'm going to divide both sides by C and divide both sides by B. And what that gives me is sine of C over C equals sine of B over B. And that actually is the cosine law. Okay, what that's saying is any ratio of the sine of that angle with its opposite side will always be the same thing. Okay, so this is it officially. Now, we use all three of them. So we say sine of A over A has to equal the same thing as sine of B over B, which has to equal the same thing as sine of C over C. Okay, but we only use two of them at once, because when we use two of them at once, we have a proportional situation and we know how to solve a proportional situation when one of those guys is not known. Okay, so in order to use sine law, you have to know a pair. So a pair means one side with its corresponding angle. Okay. All right, so let's check it out. I'll hide my head for a sec. Solve the following triangle, round side lengths to the nearest tenth. Okay, so do I have a pair? Well, I actually don't readily have a pair right now, but I can get a pair really easy because I'm just missing an angle. And if I'm just missing an angle, I know that all three sides of a triangle equal 180. So I can go 180 minus 61 degrees minus the 88 degrees and get 31 degrees. So now I have a pair, 31 with its opposite side, 31 degrees and its opposite side. There's my pair. Okay, so that's the pair I'm going to use to set up and solve for angle A, sorry, not angle A, side A and side B over here. Okay. All right, so I'm going to say sine C over C equals sine A over A. Now I know C, I know angle C, I know angle A, and I don't know little a. So I'm going to plug in everything I know. And now I'm going to solve for A. So when I cross multiply, I can multiply sine 61 times 1.8 and then divide by sine 31. If you don't like that, if you want to do it a little bit more algebraic, you're multiplying both sides by 1.8. That'll get rid of the 1.8 there. And you're multiplying both sides by A, that'll get rid of the A there, and then you'd have to divide both sides by sine of 31. Okay, that's where we're getting sine of 61 degrees times 1.8 divided by the sine of 31. Throw that in your calculator, and you should be able to get 3.1 kilometers. Okay, 3.1 kilometers. Just as a word of caution, if you go sine 61 times 1.8, if you are a TI kid, when you press sine, a bracket opens up right away. So after the 61, you got to close that bracket before you go times 1.8. Okay. If you're a child of Casio, it doesn't matter. As soon as you say times, it thinks, okay, that angle's done. Okay. All right. Now we're going to try for B. So we start with the same guy, sine C over C equals sine B over B. I know sine C is, or I know angle C, sorry, is 31 degrees. I know C is 1.8. I know angle B is 88, so I can plug all that in. And then again, you should be pausing me and trying this yourself. I'm going to go sine 88 times 1.8 divided by sine 31. And that should give you 3.5 kilometers. Okay. That's all we're doing today. Easy peasy. Okay. Did you know, maybe you did, maybe you didn't, in a triangle, the smallest angle will always pair with the smallest side length, and the largest angle will always pair with the largest side length. So that's just a helpful thing to know to make sure your answers are sort of looking like they make sense, right? If you have the longest side length, that should pair up with the longest angle. Smallest side length should pair up with the smallest angle. Side length in the middle should be the angle in the middle, okay? All right. I'm just going to hide my head for a sec. A ship at sea is sighted from 2 Coast Guard observation posts on the shore. The angle between the line of sight from post A and the line between the 2 posts is 110 degrees. From post B, the angle is 30 degrees. If the 2 observation posts are 5 kilometers apart, determine the distance to the nearest tenth of a kilometer between each observation post and the ship. Now, many of you shut down by about here because you were like, oh, there's too many words, there's too many words. You can't let yourself shut down, okay? Yes, there is a lot of words. There's a lot of information that you have to figure out. But they gave you a picture, which is very, very nice of them. Okay, so the angle between the line of sight from post A and the line between the 2 posts is 110 degrees. So we've got that right there. And then we knew that the angle from post B and the line of sight was 30 degrees. And we know we've got 5 kilometers apart from the 2 posts. Okay, that also gives us enough information to get this angle, because we can go 180 minus 110 minus 30. And that will give us a pair. okay, which I'm just going to call C for now. So angle C is 40 degrees. And now I have a pair. So our job was to figure out the distance between the observation post, each observation post, and the ship. Okay, so I need to essentially figure out this line now and figure out this line. So again, that's two sine laws. The pair I'm going to start with is sine of 40 degrees over 5. Okay, and then use that to solve each one of these. So there's kind of two little questions I have to do. So sine C over C equals sine A over A. That's sine of 40 degrees over 5 equals sine 110 over A. I'm going to go sine 110 times 5 divided by sine of 40 and get 7.3 kilometers for A. Okay, so opposite the 110, which would be this guy right here. Okay, actually, I guess I should call it A. That would make more sense. That guy there was my A. Okay. All right. Now we're going to do it again. Set myself up with the same sine C over C, but this time it'll equal sine B over B. And I've got an angle of 30 degrees. Still have that sine 40 over 5. And now to solve for B, I'll go 5 times sine of 30 divided by sine of 40 and get 3.9 kilometers. Okay. Always make sure you conclude. So the ship is 3.9 kilometers away from post A and 7.3 kilometers away from post B. Now, it is very important that you connect that the 3.9 kilometers goes with post A and the 7.3 kilometers goes with post B. Okay. That tells me you understand what the diagram is showing you and you know what side goes with what. So really important in your communication piece that you connect those two things together. Okay, awesome. Okay, so in triangle WTF, which by the way stands for way too fun, that's how we describe math, angle W is 64 degrees. Side W is 25.2 centimeters and little side T is 16.5 centimeters. Your job is to determine the measure of angle F to the nearest degree. Now, for those of you at home who don't have the book, there is the question. And let us get going. So of course, the first thing we want to do is draw a picture, okay? So I've got a picture here. I've labeled W and T and F. I know that angle W is 64 degrees. I know that side W is 25.2, which is right here. And then side T is 16.5. Now, I've been asked to find angle F. To get to angle F, I have to get angle T because I've got this pair, okay? So that tells me I can use the sine law. But then I'm going to need one of the other pair, right? So I've got side T. That's enough information to get angle T. Okay, so I actually have to set myself up to get angle T using the sine law. Once I have angle T, I can go 180 minus the two angles that I know and get angle F. Okay, so let's do it. I've got sine of W over W. By the way, I said this earlier, but just to reiterate, sometimes you'll see this written as W over sine W. That's totally okay too. This whole thing can flip, okay? It's just wherever the angle is, if it's on the top or on the bottom, it should be on the top or on the bottom of both of them, okay? So I could have just as easily said W over sine W equals T over sine T. That would have been the same thing, okay? Okay, so I'm plugging in what I know. I know that angle W is 64 degrees. Side W is 25.2. And then I know that side T is 16.5. So now I'll cross multiply. I'm going to go sine 64 times 16.5 and divide by 25.2. And that gives me sine of T. Now, don't freak out that you get this weird decimal. That's okay, because that's actually a ratio. It's not the angle, right? Sine T equals 0.588496. So then to get T by itself, I'm going to have to arc sine or inverse sine. Okay, so T will be the arc sine of 0.588496, which is going to give us 36 degrees. I immediately rounded that to the whole number because up here in the question, it said to round to the nearest degree. Now, I'm always after you guys that you don't round till the very end. But I know that a whole number minus a whole number isn't going to give me a rounding error if I've been asked to answer with a whole number. That's why I went right to the whole number, okay? Okay, so now I can go angle F will be 180 minus the 64 degrees and minus the 36 degrees. And that gives me angle F is 80 degrees. Okay, easy peasy lemon squeezy. You got this. All right, so just to summarize, we're going to use the sine law when you know a matching pair, so the opposite angle with its side, and one other side or one other angle. Okay, that's what is your kind of hint to go into the sine law. Okay, awesome. So that was it. Tomorrow we're going to keep talking about the sine law, but we're going to go just a little bit deeper into something called the ambiguous case. So it's a situation where the dimensions you've been given actually could create two different pictures, two different triangles. And so you kind of have to solve for both of them. Okay, so that's how we'll end our time together in trigonometry, is with the ambiguous case. But for now, I want you to have some time just to focus on the sine law. Make sure you're comfortable with that, and then we'll go from there. Okay, so for those of you who are my kids at school, I've posted your homework here. My kid or not my kid, make sure you're doing lots of work. And make sure you're connecting and asking questions, and make sure you remember that you can do this. Okay, I'll talk to you guys soon. Take care.